Sorry, accidentally the camera went off. Okay, we will continue. So, because of the collision of the electron with the phonons and other electrons, impurities, and lattice imperfections, this gain in momentum can be lost by successive collisions. So, the Fermi sphere as a whole attains a momentum and hence a kinetic energy. So, because of these interactions with the other electrons or impurities or phonons, this momentum gained by these electrons may lost by these interactions. In order to maintain the gain in momentum in a steady state, the electric field should be applied for a successively long time of the order of collision time tau. That is, we know that when we are applying an electric field, if we are continuously applying the electric field only, then the conduction will occur during in the metal system. If we are drawing back the electric field, the conduction will stop. That's how we can see in the metal system. So the electrical force must be applied continuously in order to maintain this momentum or kinetic energy, that is in order to move the electrons through the crystal. That is if the conduction to be occurred continuously, we have to apply the electric field continuously, otherwise it will stop. That's what this means. So when t is equal to tau, the increase in wave vector, where tau is the relaxation time or collision time, when t is equal to tau, the increase in wave vector can be represented as delta k is equal to minus e by h cross tau. Instead of t, we have put here tau, so that the increase in velocity v is equal to h cross delta k by m. This is from the previous equation, the momentum equation, and e by m. What we have done is we have substituted values of delta k here, so we will get this. If the number density of electrons is n, then the current density can be written as J. Current density is represented by the letter J is equal to NQV, because J is rho into V. Rho is the charge density. So this will become, in V is the velocity. So N into here Q is the charge, which is electron, so minus E, and V is substituting from this equation. So we will get the current density as N E square tau by M into E. So looking this equation, these terms are constant. That means J proportional to E. This is nothing but Ohm's law. Okay, so we have derived the Ohm's law using our theory. The proportionality constant is called the conductivity. So we can write J is equal to sigma E, where sigma E is N E square tau by M. Resistivity rho is defined as the reciprocal of this conductivity, so rho is M by N E square tau. And here I have given a note. The collision time tau can be defined as the average time between two successive collision of the conduction electrons with phonons or other electrons or impurities or imperfections in the lattice. That is, the moving electrons in the crystal system or the metal system will interact with other free electrons or phonons. Phonons means lattice vibration, or interactions with the impurities present in the system. So the average time between two successive collision is called as collision time tau. Now mean free path L is mean free path is represented by L is equal to Vf into tau. That is, it is like the velocity is equal to displacement by time equation, where Vf is the velocity of the Fermi sphere, because all electrons involve only Vf is the velocity at the Fermi surface, and tau is the collision time. So L is the average path. So we'll get the mean free path like this.